teach one another problems. I'm Joachim Nordström. And Nick Moffat is here as well as Natalie Partington. So there we go.
Okay, you want to go and start on... First off, were there any that you guys had specific questions on or anything?
It took me a while to finish, what number was it? Number 3. It was the whole like 157 disease-sensitive herbicide-resistant one.
Okay.
That took me a while, but I got there eventually, so.
Mm-hmm.
I don't know, what about you guys?
Yeah, that one wasn't...
There was a few calculations there.
It just took forever.
Yeah.
Yeah. Let's kind of go through them. What kind of answers did you guys get?
So for
Okay.
A was the null. That was the two traits will follow Mendel's law of segregation and independent assortment. That's what I wrote.
Yeah, that took me a while to figure out that's what it kind of wanted, because I was trying to figure out, like, are you talking about dominant or recessive? But yeah, that's what I put.
For number 3?
Yeah.
Which part?
With the null hypothesis. It just took me a while to figure out what the null should be.
Right.
Because I don't know, just like that it would follow that didn't really occur to me because it seemed almost a little too obvious.
Mm-hmm.
So.
Yeah.
But it makes sense once you figure it out.
What'd you guys get for your chi-squared on part B?
I got 0.543.
Yeah, that's what I got.
That's what I got too.
Mm-hmm.
Okay. And let's see. I'm trying to remember. I'm trying to figure out like the whole table thing and how it works.
The what?
So since that was greater, then let's see. What is it? How do they describe it on the top?
The chi-square is low, so we fail to reject.
Yeah, so if you fail to reject, it means that the null is
True.
Right. Yeah.
Right. And I figured that, but like the thing that kind of confuses me is like all these different percent confidence levels right here, where it says like p is equal to 0.99 or p is equal to 9.5 or 0.95. I mean, 0.80, 0.50. You know what I mean?
Mm-hmm.
Yeah.
Yeah. So basically, we have 3 degrees of freedom there.
Mm-hmm.
And if it's lower than like 7.815, it's gonna be fail to reject. It said if it's in the like dark area, then we reject it. If it's in
Is that generally speaking all we need to basically keep in mind for the test or whatever?
For rejecting or accepting, yeah. That's pretty much the main.
I'm sure there's more, like, you could probably get way more into detail than this, but...
I mean, I'm just asking because I've taken a biostats class, so...
Yeah, I think we've all taken that.
So, usually, this is, like, really oversimplified.
Yeah.
So just go with it.
Yeah, I'll just go with it. Like, whatever. Alright, fine. Fail to reject.
Like, yeah. Like in foundation science, when they explain something, you're like, no.
That's wrong. Because the biology department just throws like any kind of math or any kind of like other sciences like just out the window, and they're just kind of like, sure, let's just keep it.
That's how this works. For what we do, it works. So.
Exactly. Okay. All right. Did you guys have any other questions on anything specifically?
I did want to just go through like all the tables where it's asking like what kind of inheritance pattern, just to make sure that I'm like really getting it. Like I get kind of confused about autosomal recessive. Do you guys understand that very well?
I understand it fairly well. How about you?
Autosomal recessive?
Mhm.
Yeah, that one can skip. Um, can skip. So if you have two parents that um, have are both affected, all their children will be. Um, because they're all recessive traits, but can skip generations. I don't know what else there was.
Well, I feel like the most difficult thing is differentiating between autosomal recessive versus X-linked recessive.
Mm-hmm.
So with autosomal, is it both genders are going to be like equally affected?
Pretty
Yeah.
much. I
With
mean,
X-linked, it's
recessive.
men will be much more affected.
Which one?
yeah, right. The X-linked recessive. That's right. It'll be
Yeah,
Males
males.
have a harder time.
Yeah, they'll be more affected. Yeah.
yeah.
That's
One
like with muscular dystrophy and male pattern baldness and all that.
mhm. One one really like key indicator of whether it's X-linked recessive is affected mothers will have all affected sons. So if you see one where there's an affected mother, but there's one son who isn't
Oh,
affected, then you can probably conclude it's autosomal recessive.
yeah.
Yeah.
That makes sense?
Yeah, no, that makes sense because they can, if their mother's affected, they have like literally no chance.
Yeah, pretty much. They get the
Because
X from mom, and if she has recessive on both, they only need one to get the X linked.
Yeah.
So, and it's the same thing with X-linked dominant, except that all affected fathers will have affected daughters. It's kind of like the opposite,
Yeah, because actually I don't really understand. So I understand that like with the X-linked dominant, it's I mean you get that from your dad, but oh I guess no that makes sense because it's dominant not recessive and so you're going to get the X from your dad
Yeah.
if you're a girl, like you're Earl, and so yeah okay that makes sense. Just had to remember recessive and dominant for a second.
Right, because for the mother, it's not necessarily because she could be heterozygous from it, so and still have it. So it's just like looking at the different pedigree charts, how we could tell what kind of pattern it is, based solely on who's affected and who's not.
Yeah.
So what did you guys get for these then?
For 4A, I got autosomal dominant.
Me too.
That's what I got too.
And then B, I got X-linked dominant.
What I got too.
Okay. Because this was the mother thing, and all the sons had it. And then X-linked recessive for C.
Mm-hmm.
And autosomal recessive for D.
Yep, that's what I got too.
Okay.
So it sounds like you understand it pretty well. Then you're gonna understand.
Yeah, I just want to make sure, because it's like I understand things, but I can also get tripped up by detail sometimes, and I want to make sure I don't do that on the test.
Yeah.
And of course, we all know that if it's Y-linked, like all males will be affected, then only males.
Yeah.
There was one problem that was a little tricky. I think that tried to make you think it was Y-linked because it only had like males that were affected in it, but not every single male was affected as it should have been.
Sorry, which problem was that?
I'm talking about 4C.
Oh, okay.
Yeah, on 4C you could see that like it was only males that were affected, but kind of just kind of like watch out. It should be like every single male who would be the offspring of the affected.
No, you're right.
Yeah.
So on like 5D.
5D.
So in that one, I got like that chi-square was like quite high, so we had to reject the null. It says like what kind of inheritance pattern, like provide a new hypothesis that.
Oh yeah.
That was kind of like confusing to find like which one it should be.
I know which one it should be. I said 5 to 2. I don't know about you guys. I felt like that was the closest.
Which one?
D on 5D. Like
What
they
was
ask us to come up with a new null hypothesis, and
Uh-huh.
there's a 5-to-2 phenotype ratio.
5-2?
I
5
thought.
yellow to 2 gray.
I don't know. Um, well, I mean, like, after I got done with them, I kind of looked through the key,
Mhm.
checked my answers. It said something like it was like 2-1 or something.
Yeah.
Mhm.
Let me look at that really fast.
You do.
So I've done the applied genetics problems already,
Okay.
and it comes back another one. And I mean, we don't have the key for that one, but I found like one, and it came kind of like that, and um, it looked like the homozygous on that one got a lot lower, and the heterozygous got a lot higher.
Okay.
And like in that case, I said it was like some sort of where like the malaria that where the heterozygous are the best fit.
Oh, like with the sickle cell, where they have, if they're heterozygous, they have an advantage against malaria, and if they're homozygous, then they
Yeah,
like have full
yeah.
blown
What
sickle
was
cell
that one
anemia.
called again?
The sickle cell anemia, or
Yeah,
the
the
heterozygous advantage.
huh? Yeah, the
What, the
heterozygous
heterozygous advantage?
advantage. But there's another name for it. Um,
Yeah, there is.
Hold on, I have it.
Oh. Huh.
Um,
That's the answer, huh? Okay.
yeah, so over dominance, right?
Oh yeah, yeah.
I
Mhm.
think that's what it's called. Yeah, over
And
dominance.
so that's
Where
and
the
so
heterozygous produces a phenotype more extreme or better adapted than of the
Yeah.
heterozygous.
and so that's linked with the lethal inheritance thing, where having both
Yeah, the
can
middle
lead to
one.
your
Yeah.
death. But it doesn't necessarily mean that you have to die like right away. Like you can make it, past the womb and all that, I think, depending on what it is, right?
Yeah. I'm sure. Like, I just remember one example with the lethal one. It said that they die as an embryo or something like that.
Mhm.
Yeah, that was the Manx cat. You're talking about the Manx cat.
Yeah,
Yeah, that's called the lethal allele.
but
Yeah.
is all lethal? That like my question is all lethal allele? Do they die right away, or can they actually like?
Yeah, that's what I'm wondering too.
I think they die in the
Because I
embryo.
mean, something can kill you. I mean, before reproductive age without killing you instantly, right?
Yeah, so like, can you get born
That's
alive?
And so, like, what I want to know, like, what the exact like specifications are for that. It's like, if you can be born at all, does it count, or if you can only live for a little bit? So
That's a good
maybe,
question.
I
I
think it
actually do
varies
not
from
know
case
the answer to
to
that.
case.
yeah, maybe we can just include that as a question in the link.
Yeah, I do think it varies from case to case, though. Like for the
Mhm.
Manx cat, I think they died before, like when they became an embryo. But like
Yeah,
I think they use Huntington's disease as an example too, where they die like young, like at 6 or 7 or something like that.
Well, Huntington's
I
is
thought Huntington's was like in your when you were
20
middle
to
aged.
60. Yeah, yeah, it comes in at that point.
Yeah,
Okay.
because that's like when you're like you won't know you have it until you're
It's
maybe late
basically
30s,
like
early
a line of
40s.
proteins. If you have like a long line of protein, like the longer the line is, the earlier
Yeah,
it's being set on.
yeah,
So
yeah.
if
Just
you're
be a good
rare enough,
question to
you'll
ask,
get
though.
on in their 20s or something, but usually more like 40s, 50s, and so on. I guess. But not fun.
No, not really.
Yeah.
Okay. Did you guys have any other questions?
Good question. Let's see.
You guys feel like you understand? There was only one problem in the group problems that actually required us to use the binomial expansion. Are you guys pretty comfortable with that?
Yeah.
Yeah. I mean, it's not. It's just plugging numbers in.
Yeah.
So.
Pretty much, yeah.
As long as you know how to use your calculator, it should be good.
Yeah. I'm glad we have those.
It'll take a while to do them without them.
Yeah.
It's possible, but
I don't know what people did. So, okay. I think I'm good on questions, unless you guys have anything else.
yeah.
Oh, I think so. I think I
Good luck
understand.
on your tests.
Yeah,
Oh, yeah,
so
thanks.
it's due to Saturday at midnight, right?
Yep.
Yeah.
Okay.
It should be fun. All right. Well, same. Should we do? Should we shoot for 9 again? Well, no. Wait. I'm speaking my time. 1 o'clock again next week. Sorry about this
Yeah.
week.
Sure, that's fine. We can
No,
shoot at 1 o'clock next week.
yeah, that works for me.
Okay. Awesome. So I will stop recording now.